Molecules, compounds, and reactions. Molecules are made up of two or more atoms combined by a chemical reaction. Chemical reactions involve the sharing or donating and receiving electrons between the atoms. Chemical reactions combine atoms to make a more stable molecule. When hydrogen gas is in contact with oxygen, they chemically react to produce water, which is more stable than either gas. Some examples include water, which has two hydrogens and one oxygen, and you can hopefully see the little subscript there that says two hydrogens, and if you don't have a subscript, that means you just have one of the atoms. Carbon dioxide, CO2, one carbon, two oxygens. Salt, sodium chloride, one sodium, one chlorine. And then HCl, hydrogen chloride. A compound is a substance that is made up of two or more elements that are chemically combined. This is similar to the definition of a molecule, which is made up of two or more atoms. And the formulas for the compounds are just the same as the formulas for the molecules. Here are some compounds. We have water, or H2O, made up of hydrogen and oxygen. So you have two gases here. They combine to form a liquid. Salt is made up of sodium and chlorine, NaCl. Two hydrogens form a chemical bond to form a hydrogen molecule in a chemical reaction. And it's written like this, and we use the symbols for the elements. H plus H yields H2. 2 means there's two. Or you could write it this way, put the 2 in front of the H over here. That's a little shorter. The elements or molecules on the left side of the equation are the reactants. The elements and molecules on the right side are the products. Chemical equations have coefficients and subscripts. Coefficients in blue, right here and here, that indicates the number of particles. Subscripts, right over here, are in green, and we circle the other one. They indicate the number of a type of atom in the particle. Normally, we don't show these if they are number 1, but we've added them below for clarity. So normally you would show this as 2H yields H2. But this, of course, is also valid. According to the conservation of matter, and this is how it does work too, a chemical reaction cannot change the number of each type of atom, just how they are combined to form particles. In this case, there are two hydrogen atoms on each side of the equation. On the left side, there are two particles with one hydrogen atom in each. On the right side, we only have one particle, but each particle has two hydrogen atoms. The particles and the number of particles are different, but the number of hydrogen atoms is the same. That's the conservation of matter. A chemical reaction cannot create or destroy atoms, nor can it change one type of atom into another. A chemical reaction just changes how atoms are combined, changing one set of particles into another. So the number of each type of atom has to be the same before and after a chemical reaction. As we've now said a couple times, this is conservation of matter. The mass of each atom is also unaffected by a chemical reaction. Since the mass and number of each type of atom is unchanged, the total mass of the atoms before and after a reaction is the same. If we start with 4.2 grams of substances, we end with 4.2 grams of substances. This is the conservation of mass. We now will have a slightly more complex reaction. This is the burning wood reaction. It is a spontaneous chemical equation for burning wood. Wood is made up of glucose, represented by C6H12O6, 6 carbon atoms, 12 hydrogen, and 6 oxygen. It combines with oxygen in the air, then that yields 6 molecules of carbon dioxide and 6 molecules of water. While the reaction is spontaneous, it does need a little energy to get started. And that's why wood won't burn if it's just sitting there in oxygen. It needs a little more energy, and that's why you start it with a flame. After burning the wood, we are left with carbon dioxide and water. Now, carbon dioxide is a gas. Water in a flame will form water vapor, which behaves like a gas. The result is that the mass of the wood goes into the air. That's why the mass of the wood seems to disappear. The energy to create wood, that is glucose, is provided by sunlight, which reverses the reaction of burning wood. The arrow is pointing to the left this time, and that will be called the photosynthesis reaction. Life has evolved to capture the energy of sunlight and store it as glucose. Glucose is then used to build plants and trees, including our food. And its energy is released when it is burned or when needed by living cells during respiration. Photosynthesis takes water and carbon dioxide from the air and turns it into solid glucose plus oxygen. The trees we see around us got their mass from the air. When you burn wood, the light and heat you see and feel is the energy from the sun, which was used to create the wood. The process of forming glucose through photosynthesis is the basis of almost all life on Earth. The reactants, that's what goes into photosynthesis, are water, H2O, carbon dioxide, CO2. The products that come out of photosynthesis are oxygen and glucose. Glucose is sugar, a simple carbohydrate containing carbon. The individual atoms and molecules of carbon, hydrogen, and oxygen are joined together to make this molecule. Another reaction. The alkali metals are in group 1 of the periodic table and are soft and highly reactive with certain other elements and compounds. Here they are. We talked about them a while back. Specifically, sodium, with 11 protons, reacts very strongly with water in the following reaction, where sodium plus water yields sodium hydroxide dissolved in water and hydrogen gas. The symbols here, S means solid, AQ means the compound is dissolved in water, the real word there is aqueous, and G means gas. Now, what do we mean by very reactive? Well, if you were to drop a small piece of sodium metal into a cup of water, the energy released by that reaction ignited the released hydrogen, resulting in a large sound and a flame. That's what we mean by very reactive. If you were to drop a little block of aluminum in the water, nothing would happen. At the other side of the periodic table are the group 8 elements, also known as noble or inert gases. They do not react with other elements or molecules at all. They are very stable. Helium gas is lighter than air, so when it is contained in a balloon, the balloon floats. It is non-reactive, so even if it leaks, it doesn't cause any damage, unlike the sodium plus water reaction. Argon gas is used in light bulbs. The inside temperature of a light bulb is 2,550 degrees Celsius. If air was used in a light bulb, the air would react with the tungsten filament, which would cause corrosion, reducing the lifetime of the bulb. Argon is non-reactive, so even at high temperatures, there is no reaction.